Yo, package on you.
Is the president? The president said he's from it. That's why you can't.
Hey, I don't really know my. But mom, no, I don't want to put on my campus.
Why you have friends are in the office?
Yes, it's a photocopy. Photocopy.
No.
I'm out campus. But I'm going to look back and go. That's what I'm about. That's it. Oh, baby. But then you rank out this.
I do show you already. I reach 400 views.
Okay, but it's the first time I'm pitching 500. Where? For myself.
This not to reach 300.
This one.
No.
Snap. I don't know. Is it active?
On Snap than WhatsApp.
Yes. Yes. So sometimes I have like 3,000. But a lot of people that I've been snap with, I said, since they are not my friends, I say, me, not friendly people come.
How do you channel me?
Me, I have Nancy, I have deleting mistakes like for WhatsApp. You see, the entire, like, as I was doing my agenda, because I don't have to do my
before.
no, like 400 plus.
I'm just asking. I'm doing some analysis.
Outside.
Maybe you have, like maybe
This part. I was really like,
why you
this
laugh?
part, this part,
If you laugh, so you will not know.
okay, this part, I was really like this,
So in few minutes we'll be starting. So we want to set up things. And at 6:30 we begin with this section. So metrics. Look at so we look at metrics. Look at some basic things regarding metrics. So looking at how to basically maybe add and multiply matrix by a scalar. Look at matrix multiplication, transpose, some simple aspect of it. Then the most important thing, look at the systems of linear equation, how to solve systems of linear equation using matrix. There are several methods, but I will look at a few. Then we'll be done. So basically, so stay around 6:30. We start. Um, you can share the link with your colleagues, your friends, your course mates who do not know of this. Because I'm here and I'm going to make sure that any challenge that you people have, we are going to see you guys through. So yeah, we are going to demystify the metrics. So we are going to make it very simple. Yeah. So you can tap on the share symbol and share the link with your colleagues in the various classrooms. Let them know that we are here. Yeah, I'm seated and I'm ready to go. So your colleagues in the various classrooms. Let them know that we are here. And as we go on, if there is any means that you have a challenge, a question to us, you can type it in the comment section so that we can know what your challenge is. You get it.
you know, you see how they organize this equation. You see,
Then I will get please charge my laptop. I have it charged.
This is your
Oh,
No,
no, there's
that's the toilet.
are you charging with this one?
Yeah, I'm sorry.
I will use the laptop here. There are some that will type, so I have to monitor from this. So
This one.
Not charge with it. When you go and
so yes, just as I was saying, we are starting at 6:30. You can invite your friends to join us. We are going to look at metrics. We're going to look at some operations of metrics, look at transpose, how to solve metrics, system of linear equation. We look at the row echelon, reduced row echelon, look at Gauss-Jordan method, and there are so many methods that we can use. And we look at some tricks. Assuming you are given a 5 by 5 matrix to find the determinant, how do you go about it within a fast rate?
oh, if you tell us that I want to go for this for Alexa secretary. You don't know the person is my boy. I want to have Jesus Christ. Let me reply. My boy, how is it from Mesa? I suppose agenda do hands. You see the thing, I think you do the one way. But if I can do it, let's command now. These are serious nigga. I'm excited for coming. Me, I don't rate it that much. It's when I rate it, I don't know. It was
Me, honestly, I just feel like
then you can buy that food. Like it's in that food, you get that food. Whatever, it's not bad though. But yeah, I think but it's not bad. It's not bad. It's not bad. But then you from Kuja, my mouth so bad. You borrow me some money, but I'll give you by minute. I'll give it to you. At least this is it. I don't know why the guy is playing out money.
and how much you pay.
Does it pay twice?
Let me try for myself.
Oh, you try it. That's what I'm saying. It's
I'm
not
sure
bad.
if they are saying they don't rate it,
Hey, it's not like it's bad. It's good because you know when I opened it first, I was sure that there was.
All right. So good evening. Trust we are all doing well. So if you can't hear me clearly, let me know. If you can, then we will continue. So we are going to look at metrics. Yes, metrics. So that's what we are going to look at briefly here. So let's look at metrics. Metrics. So if I have, let's see, a metric, we are looking at the array of numbers. So assuming I have a matrix A11, A12, A13, A14. So this is what basically we call a matrix because we have an array of what? Of numbers. So if I'm going to bring numbers, we are going to have, let's say 2, 1, let's see 4, 3. There's a matrix. Let's say we have something like B is equal to 1, 0, 0, 3, 4, 5, 6, 3, 1. This is also a matrix. So when we talk about matrix, we are looking at array of what? Numbers. Now, without wasting my time, we have what we call the size of a matrix. Size of a matrix. So we are talking about the rows and the what? The columns. Now, the rows we are looking at the horizontal. That is the row. Unfortunately, when we were in school, the teachers were confusing us that this one is the row. Rather, these ones are the columns. So the columns are the verticals. The columns are the verticals. So in the first example that I gave, we had two rows and two columns. So it's a 2 by 2 matrix. That is this one. Now, if you take the matrix B, it also have 3 rows and 3 columns. So it's a 3 by 3 matrix. A 3 by 3 matrix. Now, if I have, let's say, a matrix C, which is let's say 2, 4, 3, 1, 6, 3. So in this case, we have 2 rows and 3 columns. So this matrix is a 3 by 3. Sorry, a 2 by 3 matrix. So the matrices are named according to the number of rows, that is the number of rows by the number of what? Columns. So that is how matrices are named. Now we want to move on. Now, since we know what matrices are, let's look at some operations of matrix. So let's look at some operations on matrix. Operations on matrix. Now, in the operations of matrix, we need to know some rules. In terms of addition and subtraction, uh, oh, sorry, subtraction. In terms of addition and subtraction operation of matrix, so subtraction, we have to know that we can only add and subtract. So you can only add and subtract matrices of the same size. Matrices of the same size. So if I have a matrix which is a 2 by 2 matrix, I can only add this matrix also to a 2 by 2 matrix. I cannot add a 2 by 2 matrix to a 3 by 2 matrix or a 2 by 3 matrix. So if I'm going to add or subtract matrices, they must be of the same size. So if I have, let's say, matrix B, which is a 3 by 2 matrix, and matrix C, which is a 3 by 1 matrix, I can't add matrix B and what? C, and I can't perform an operation where I'm going to subtract matrix C from B because they don't have the same what size. So we have to take note that in performing operation on matrix with addition and subtraction, we can only add or subtract matrix of the same size. What am I talking about? I'm talking about, let's say, matrix A is equal to 1, 2, 4, 3, and matrix B equal to, let's say, 3, 1, 5, 1. Now, if you look at this matrix, let me change the color. If you look at this matrix is a 2 by 2 matrix because it has 2 rows and 2 columns. If you take this matrix to, it is also a 2 by 2 matrix. Excuse me. It's also a 2 by 2 matrix because it has 2 rows and 2 columns. So if I'm giving this matrix to perform an operation on it, it can an operation in the context of addition and subtraction, it can be what? Possible. Do you get it? So what is the general formula? So this is the general formula. If I have a matrix A, which is, let's say, A11, A12, A13, then I have A21, A22, A23, and I have A31, A32, A33. I have this matrix here, and I have another matrix of the same size. Let me call it B11, B12, B13, and I have B21, B22, B23, and I have B31, B32, B33. Please share the link when you do food here. You get it? If you are enjoying this tutorials, make sure you share it for your colleagues to join. So how do we add? We add matrix occupying, how do I say, the same row and column. So if I'm going to add these matrix A and matrix B, you see there is an element here and there is an element here. They have the same row and same column, so I can add them. So that will be A11 plus what? B11. Then I come here, this and this, they are occupying the same row and same column. That will give me A12 plus what? B12, right? Then if I take this one and this one, they are occupying the same row and column. So A13 plus what? B13. So we continue in that wise and fill it. So this will be what? A31 plus what? B31. Then what? A32 plus what? B32. Then what? A33 plus what? B33. So you can only add the elements that are occupying the same position. Do you get it? That is why we are saying that you can only perform um, the operation of addition and subtraction of matrices if the matrices are of the same size. So let's take an example. If I'm going too fast, let me know so that I can take my time and teach. All right. So if no one has an issue, we can continue. They didn't allow for live interaction. Okay, so let's continue. So let's take an example. I'll start with a 2 by 2 matrix. So example, I have matrix A is equal to 2, 1, 3, 4, and matrix B is equal to, let's say, 6 minus 5, 8, then what? 9. So if I want to add A plus B, that will be what? 2, 1, 3, 4 plus 6 minus 5, 8 what? 9. Right? And so if I continue, I'm going to get what? I'm going to get 2 plus 6. Then this side will be 1 plus minus 5. Then I'm going to get what? 3 plus 8. Then 4 plus what? 9. So if I evaluate this, I'm going to get 8, then what? Minus 4, 11, and what? 13. So this is the addition, right? Let's take another example, a 3 by 3 matrix and see. So if I have matrix A to be equal to 1, 2, 5, 6, 7, 8, then 9, 1, 1. That is my matrix A. My matrix B is 7, 3, 4, 1, 2, 2, 6, 3, 1. Now I'm supposed to perform the operation of A plus what? B, right? So in this case, it's going to be 1, 2, 5, 6, 7, 8, 9, 1, 1 plus 7, 3, 4, 1, 2, 2, then what? 6, 3, 1. So I can only add matrix occupying the same position. So this one and this what? 7. So I'm going to get this. I'm going to get 1 plus 7, 2 plus 3, 5 plus 4. Then here is going to be 6 plus 1, 7 plus 2, 8 plus 2, 9 plus 6, 3 plus 1, then what? 1 plus 1. So if I evaluate this, the first one I'm going to get, if I evaluate this, the first one I'm going to get 8, 5, 9, 7, 9, 10, then what? 15, 4, 2. So that is it. Assuming we are supposed to find b minus a. B minus a. So I'm putting them together. So b minus a, that's going to be, what is b? Can't I move this thing from here? So b minus a, what is b? B is what? 7, 3, 4, then what? 1, 2, 2, then 6, 3, 1, minus what? A, 1, 2, 5, 6, 7, 8, then what? 9, 1, 1. If you are going to do this, I can only perform the operation of values occupying the same position. So this is going to be what? 7 minus 1, then the next one is going to be 3 minus 2, the next one is 4 minus what? 5. Here, this row is going to be 1 minus 6, 1 minus 6. This is going to be 2 minus 7, and this is going to be 2 minus 8. Next one is going to be what? 6 minus 9, got it right. Then 3 minus 1, then 1 minus 1. So if we let me write it here. Sorry, I'm going to continue it here. So this is going to give us, let me use the red marker. So to show where I'm continuing the operation here. So this is going to give us 6. This is 1. This is minus 1. This is minus 5. This is minus 5. This is minus 6. This will give us minus 3. This will be 2, and this will be 0. So now we've seen how to add and what, and perform subtraction operation on matrix. What is it? Yeah, yes, please. Yeah, hello. Yes, yes, we started. He said, oh, we started. The sound is working. Okay, sure. So we will we'll continue. We'll continue. So we've looked at the addition and subtraction of vectors. Let's look at, we want to begin gradually. Do you get it? So we want to look at scalar multiplication of matrix. Scalar multiplication. Scalar multiplication of matrix. So if I have a matrix A, assuming it's A11, A12, A21, A22, then I have a scalar which is k, and I multiply it to the vector. Simply means that all the elements in the matrix will be multiplied by the k. That's what it means. So if I have a matrix and it's being multiplied by a scalar, all the entries in the matrix will also be multiplied by that scalar. So assuming I have matrix A to be 1, 1, 1, 3, 4, 0, 0, 0, 0. And this matrix is multiplied by a scalar. Let's see. I say find 2a. That is, the scalar is 2. So it means that all the entries will be multiplied by 2. All the entries will be multiplied by 2. all the entries should be multiplied by 2. And that is what the scalar actually means. Scalar multiplication of vector means. So when all the entries are multiplied by 3, we are going to get what? We're going to get 2, 0, 0, 6, 2, 0, then what? 8, 0, what? 2. That's what scalar multiplication is all about. So with that in mind, we want to put or box everything together. That is addition and subtraction of a matrix and what? Scalar multiplication. Scalar multiplication. So after learning these two, so this is what we have recently learned. So this is scalar multiplication. You just take the scalar and use it to multiply each of the elemental entries of the matrix. Do you get it? And so in this question, this was the entries of the matrix. These were the entries of the matrix. Then the matrix was multiplied by a scalar, which is 2. So each of these entries, you have to multiply each of them by what? 2. Are we okay? All right. So let's take some example. So example 1, given matrix A to be equal to 4, 6, 8, 1, 3, 5, 2, 9, 3. Matrix B is equal to matrix B is equal to 8 minus 1, 3, minus 6, 3, 4, 7, 1, 1. So this is the matrix. Now they said find let's say I 2A plus B. I 5A I 3D minus 2 what? A. So this is the question given to us. So here we are combining both addition and subtraction of matrix, then scalar multiplication of matrix. We are combining them. We will be moving very fast. From here, we look at multiplication, then we look at transpose, then we look at systems of linear equation, try some few methods, then I think we'll be good to go. So let's see. Then we look at how to calculate eigenvalues and eigenvectors if time will permit us. So let's see. We have matrix A. So the first one, they say we should find what? 2A plus what? B. Means that the matrix A is being multiplied by what? 2, right? So this is equal to 2 multiplied by 4, right? All the entries. Use 2 to multiply all the entries. 2 multiplied by 6, 2 multiplied by 8, then what? 2 multiplied by 1, 2 multiplied by 3, 2 multiplied by 5, then what? 2 multiplied by 2, 2 multiplied by 9, 2 multiplied by 3. And so this is going to give us what? 8, this is 12, this is 16, this is 2, this is 6, this is 10, this is 4, this is 18, and this is 6, right? Now, they say we should go ahead and add it to matrix B. So what is matrix B? 8 minus 1, 3, minus 6, 3, 4, 7, 1, 1. So if we are adding these two, I'm projecting it here to continue. I just add the what? The entries. So I add this to this because they occupy the same position. Add this to this, add this to this, add this to this because they occupy the same position. So 8 will be added to 8, 12 will be added to -1, 16 will be added to 3, 2 will be added to -6, 6 will be added to 3, 10 will be added to 4, then what? 4 will be added to 7, 18 will be added to 1, and 6 will be added to 1. Performing this operation, we are going to get 16, 11, 19, minus 4, 9, 14, 11, 19, and what? 7. And that'll be the final answer for the first question. So I'll do the second one and I'll let you go and try the third one at home. Take it as your homework. You understand? So the next one is 5e. So 5e, scalar multiplication. So we are using 5 to multiply the entries of the matrix. What E? What is matrix E? This is matrix E. You get it? So 5 by 4, right? 5 by 6, 5 by 8, then what? 5 by 1, 5 by 3, 5 by 5, then we have 5 by 2, 5 by 9, and 5 by what? 3. And so if I evaluate this, I'm going to get what? Let me change the color. I'm going to get what? 20. This is going to give me 30. This is going to give me 40. This will be 5, 15, 25, 10, 45, and what? 15. So this is your take away. Take away, take away, take away. This will take away, and this one. So go and try it and see. All right. So from here we want to look at multiplication of matrix. I think in senior high school we were taught how to multiply matrix, but it was limited to a 2 by 2 matrix. And I'm sure in class you've been taught, but some are still struggling. So we look at how best we can do it. Look at how best we can do it in brief. So multiplication of matrix. Now you see, when we're looking at the addition and subtraction of matrix, we gave a rule. If you would recall, we said that you can only add and subtract matrices that have the same size. That have the same size, So the multiplication tool has its own rules. We don't just take any matrix and multiply. There are rules that we need to abide. You cannot multiply any matrix. Just as the same way you cannot just add any matrix. So look at it and how to go about it. So let's see. So multiplication of matrix. Multiplication of matrix. Now remember that I taught you the size of a matrix is made up of the rows and the columns, right? So let me do it. Ni cross Ng, the rows and the columns, very important. Now if I am going to multiply a matrix, first of all, let's take maybe matrix A has the size M cross P, and matrix B has the size Q N, right? I can only multiply these two matrices. So when we talk about the size, we are looking at the number of rows. So this is standing there for, let me erase this and do it again. Initially, I explained what size is. Size is simply, you are looking at the number of rows and columns that the matrix have. So if I have a matrix E and has M number of rows and what? P number of columns. Then I have matrix B also having Q number of rows and N number of columns. I can only multiply these two matrices, this and this. I can only multiply them if the column of the first matrix, is equal to the row of the second matrix. I can only multiply them. So assuming I want to multiply A times B, I can only do so when the column of the first matrix is equal to the number of rows that the second matrix have. So in this case, assuming I have matrix A with 2 rows and 3 columns, and matrix B with 3 rows and 1 column. Now if you look at these two matrices and I want to find A times B, the first matrix, what is its column? 3. The second matrix, what is its row? 3. Now they have the same number of rows and column. So the first matrix has 3 columns and the second matrix has 3 rows. So I can multiply A times B, but I cannot multiply B times A. Now let's see. If I'm taking B times A, what is the number of rows? What is the size of B? 3 by 1. What is the size of A? 2 by 3. What is the last column here? The column of the first matrix, 1. What is the row of the second matrix? 2. Are they the same? They are not the same. So although I can find A cross B or A times B, I can't find B times A, because the first matrix, its column, is not equal to the last matrix, its row. So the rule here is that if I'm given two matrices, let's say matrix A and matrix B, and I'm asked to find their product, I should make sure that the first matrix that I'm going to take, its column or the number of columns it has should be equal to the second matrix, the number of rows it also would have. So in matrix, multiplication is not commutative. Remember what commutative is? A by B is equal to B by A. Matrix and this does not exist in matrix. In matrix, multiplication is not commutative. It cannot happen. Do you get it? So we should take note that we can only multiply matrix if the first matrix, the number of columns it has, is equal to the second matrix, the number of rows it also have. So let's take an example and see. So assuming I have matrix A to be equal to 1 and 3, then 2, -1, and I have matrix B is equal to 2, 0, -4, 5, -2, 6. I have these two matrices. Now let's look at the size of matrix A. It is 2 rows, 2 columns. Let's look at the size of matrix B. 2 rows, 3 columns. Can we multiply these two matrices? Yes. Why? Because the number of columns in matrix A, can we find A by B? Yes. Because the number of columns in matrix A is equal to the number of rows in matrix B. But can we find B by A? No. Because the number of columns here is not equal to the number of rows here. So this is not possible this is what possible. Please, are we okay? So knowing that, knowing the condition that will apply for multiplication of matrix to occur, let's look at how to actually perform the multiplication. Okay, so let's see. Now this is how we multiply matrix. So if you are going to multiply a matrix, you take the row. So assuming I'm multiplying A by B, so I take the row here, use it to multiply the column here. Do you get it? Then I take the same row, use it to multiply this. Take the same row, use it to multiply this. Right? Sorry. Yes, then when I move on, I will take, when I'm done with the top side, I'll come and take this row, use it to multiply this one again. Take this row again, use to multiply this again. Take this row. So let's see. So in the first contest, I'll take this row, right? So that is 1 will multiply 2 plus 3 will multiply 5. That will give me this first entry here. Then I will still take the row, use it to multiply this column. That will be 1 multiplying 0 plus 3 multiplying 2. That will give me another entry. Then I'll still take the first row, that is 1 multiply minus 4 plus 3 multiplying 6. Do we see that? Then I'll come to the second row. So we in matrix we multiply using this row by column. Row by column. So you take a row, use it to multiply the columns, take another row, use it to multiply a column. So basically that's what we do. So the second one, we take this row, use it to multiply the column. So it's going to be 2 by 2 plus minus 1 by 5, right? Then take that same row, use to multiply the second column. That will be 2 by 0 plus minus 1 by 2. Do the same for the next column, that is 2 by minus 4 plus minus 1 by 6. And so we can expand and simplify this. This will give us 2 plus 15. This will give us 6. This will give us minus 4 plus 18. This will give us 4 minus 5. This will give us 0 minus 2. And this will give us minus 8 plus minus 6. So if I simplify this, I will get 17, 6, 14, minus 1, minus 2, and minus 14. So yeah, this is what we have. What? Have we made a mistake? No. I think this one was -2, right? 3 times -2, I didn't see. So it's going to make a -6, no, -6. So yes, basically that's how we multiply a matrix. You take the row, multiply by the column. Take the row, multiply by the column. Let's take another example and see. Let's take another example. Let's see this example. Let's see this example. Let's say matrix A is equal to 2, 1, then 6, 3, then 1, 5. And matrix B is 3, 2, 1, 1, 4, 6. And we are asked to find A by B. That's the first one. And the second one we are asked to find B by what? A. So this is the question that they are giving to us. Now let's see if these are possible. You know. So if I take matrix A, what is the size? It is a 2 by, sorry, it's a 3 by 2 matrix. If I take matrix B, it is what? A 2 by 3 matrix, right? So this is equal to this. So I can find A by what? B, right? Okay. So I'm going to multiply this matrix 2, 1, 6, 3, 1, 5 by 3, 2, 1, 1, 4, 6. And we are multiplying, right? And I said, how do we go about it? How do we go about it? I said in matrix, we do it what? You take a row, use it to multiply a column, right? So this row, I'll use it 3 times. So I'll use this row to multiply the first column. Use this same row to multiply the second column. Use that row to multiply the what? The third column. Then I'll come and take another, when I exhaust it, I'll come and take another row. So I've taken this row. Do same for this, this and that. Then come and take the last row, do same for this, this and that. So when you take the rule, you make sure you use it to exhaust all the column, all the columns. So if I take the first row here, I'll use the first row to multiply the first column, second column, and third column here. Then I'll come and take the second row, do same, take the third row and do same. So let's see. Grab my bread. Abeg, abeg, dem get water for there. Water. Dem no get. If some no dey, dey fit use am finish. Fit get some. All right, so let's see. So I want to do the multiplication. So it's going to be this by this. So that's going to be 2 multiplied by 3 plus what? 1 multiplied by 1. Are you seeing that? Then I'll do same for this guy. That will be what? 2 multiplied by 2 plus what? 1 multiplied by 5. Then I'll do same for this guy. So 2 multiplied by 1 plus what? 1 multiplied by what? 6. So you see, we are working. Then, so I have exhausted the first rule after using it to multiply this side. Then I'll take the second, rule. So if I take the second row, I'll use it to multiply the first column, second column, third column. So that's going to give me what? 6 by 3 plus 3 by 1. That's the first one. And I'm going to get 6 by 2 plus what? 3 by what? 4. And the third one is going to be 6 by 1 plus 3 by what? 6. So I'm done with the second, right? Then I come to the third. The third is going to be what? I take the third row, use it to exhaust these columns. So that is going to be 1 by 3 plus 5 by 1. Then I'm going to get what? 1 by 2 plus size plus so plus 5 by 4, then 1 by 1 plus what? 5 by what? 6. So after expanding this, I'm going to get what? 6 plus 1, 4 plus 4, 2 plus 6. Then here I'm going to get what? 18 plus 3, 12 plus 12, 6 plus 18, then 3 by 5, then what? 2 by 9, 2 plus 9, sorry, then 1 plus what? 30. So if I put things in place, I'm going to get what here? 7, 8, 8. This will be 21, 24. This will also be 24. This will be 8, and this will be 11, and this will be 31. And so that will be my answer. Very simple. Now, there is something that we have to know here. You see, we use this to determine whether the matrix would be, the multiplication of the matrix would be possible. Now, what is left is the size of the matrix that you get after multiplication. So you see that after multiplication, we have a 3 by 3 matrix. So always you can use this to check whether what you've done is right. So we realize that we use these two to check if the matrix multiplication will be possible, right? Then you use these ones to check if what you've done is right. So after multiplication, we are supposed to get a 3 by 3 matrix. And did we get a 3 by 3 matrix? Yes, we had a 3 by 3. Now the next question said we should find B what? A. So B, what's the size of B? As 2 by 3. What the size of A? As 3 by 2. Is it possible? Yes, it's possible because the B is 2 by 3. Okay. It's possible because the column here and the column here. The column here and the row here are what? Are equal. So after multiplication, we are supposed to get what type of matrix? We are supposed to get what? A 2 by 2 what? Matrix. I'll leave that one to you for you to go and try home as what? An assignment. Now we are done with multiplication of matrix. Multiplication of what? Matrix. We want to look at something. We want to look at how to find the transpose of a matrix. How to find the transpose of a matrix. Now, when we are done with the transpose of a matrix, we can switch. We can switch to look at system of linear equation and see how we can use matrix to solve system of linear equation. If your colleagues are not here, make sure you share the link with them. Share the link with them so that they can also join. Share the link with them so that they can also join. So we are going to move on. So we are going to move on and look at transpose of matrix. So transpose of matrix. Transpose. Now, these things that we are doing, don't forget, we use it in the near future when we enter into solving of systems of linear equation. So, transpose of a matrix, we are seeing that a transpose of the matrix E. So, if I have a matrix E, A transpose is written as this. And how do we find the transpose of a matrix? So, if I have a matrix E and has a size of what? M by N, then its transpose will be what? N by what? M. So in transpose, or when we are transposing a matrix, we just take each row and make it what? A column. You get it? So if I have, let's say, matrix here, something here, let me see X, 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 let me see A, let me say X1, X2, X3, X4, X5, or you let me use matrix notation. Uh, so if I have a matrix, so this is my matrix A11, A12, A21, A22. So we know this part of the matrix is the row, right? This is the row, this is the row, this is the row, and this part is the column. This is the column. So assuming this is my matrix A, if I'm asked to transpose this matrix, it means that I take the row and make it a column. So that will be A1, 1, A1, 2. And I take this row, make it column. That will be what? A21, what? A22. So that's basically what the transpose is. Take the rows and make it what? A column. Or take the row element, make it column element. If I have, let's say, a matrix, let's say matrix A, let's see, I have A11, A12, A13, A21, A22, A23, and I'm asked to find the transpose of this matrix. I take the row and make it what? Column. That will be what? A11, A12, A13, and I'll come and take this row and make it column A21, A22, A23, and that is what my transpose. As simple as that. Very simple. So that's how. So when we are asked to find the transpose of a matrix, so if I have a matrix A, he has to find a transpose. Simply take the row element and make them column elements. Just as we did here. So let me use the red. Just as we did here. This was the matrix A11, A12, A13, A21, A22, A23. In finding a transpose, I took the first row and made it what? So it's like this. I have a stick in this direction. I just rotate it. I just rotate it so that it stands like this. You get it? Aha. So this is the rule. You just rotate the rule and make it what? Column. Take the second one and replace, bring it here. Take the third one and bring it here. That is how to find transpose. As easy. Simple as that. Simple as that. It's very important to know how to find the transpose of a matrix. So let's see. Let's take some example. So we are still looking at transpose of a matrix. Transpose of a matrix. Transpose of a matrix. So I have matrix A, which is, let's say, 2, 1, 4, 5, 3, 7, and I'm asking you to find A transpose, right? So finding A transpose will be equal to what? Take the rows, make it column. That will be what? 2, 1, 4. Take the next row, make it column. That will be what? 5, 3, 7. And so A is this. So A is this 2, 1, 4, 5, 3, 7, and the transpose is 2, 1, 4, 5, 3, 7. I'm sure that. If I also have, let's say, matrix A to be 8, 1, 9, 3, 4, 5, 2, 6, 3, and I'm asking you to find A transpose. Let me call this back matrix B. I'm asking you to find matrix B transpose. Simply take the rule here, make it column. So that will be what? 8, 1, 9. Take the rule here, make it column. That will be what? 3, 4, 5. Take the rule here, make it column. That will be what? 2, 6, or 3. And so that is what? The transpose. Now there are some properties under the transpose that we need to take into consideration. So let me write them here. The properties under transpose. If I have A plus B and I'm asked to find their sum transpose, it's the same as A transpose plus B transpose. That's the first property. If I have K scalar multiplication of a matrix afterwards transpose it, then I can also see that K after transposing, then I multiply it by the scalar multiplier. Then also if I have A transpose or transpose, I will still get back what? A. So it's like this. I have A transpose, I transpose it again. For instance, this, and I'm asked to transpose it again, transpose this one again, this B. So it means I'll take the rule and make it column. That will be 8, 3, 2. Take this rule, make it column. That will be what? 1, 4, 6. Take this rule, make it column. That will be what? 9, 5, 3. Now can you see it's the same as the original B? 8, 1, 3, 3, 4, 5, 2, 6, 3. So anytime you have an already transposed matrix, you are transposing it again for the second time, it will give you the original matrix. And if I have A multiplied by B transpose, it's the same as B transpose A transpose. Not my brothers and sisters, not A transpose B transpose. It is not this, but rather this. Now these are the tricks that electrons will use it, will play around, in certain questions, because you know that questions under matrix when you are solving is time consuming. So assuming I give you matrix A, I say matrix A is 2, 4, 1, 3. Maybe I give you a 5 by 5 matrix and I say find A transpose transpose. It's the same as what? A. So there is no need for me to do calculation. But if you don't know, you do A transpose. After that, do A transpose transpose before you get your answer, and that will waste your time. You get it? So these properties are very important that we need to keep in mind. We need to keep them in mind. Keep them in mind. All right. So with that out of the way, we can look at system of linear what equation. System of linear equation. System of linear equation. So that's what we are going to look at briefly. So look at system of linear equation. Now, when we talk about system of linear equation, we have two forms. We have the inconsistent and the consistent. So we have the inconsistent and the what? Consistent. Now let's look at these graphs. Let's look at these graphs. This y is equal to mx plus c. And we call this y1, x1, c1. And this y is equal to mx plus c is y2, x2, c2. Now if you look at these two lines, if you look at these two lines are never going to meet. And so these two lines will not intersect. And because they are not going to intersect, there is no way there's going to be a solution for these two equations. So these two equations, if we are going to solve them simultaneously, there's going to be what? No what? Solution. And so this system of linear equation is considered to be what? Inconsistent. Because if I'm going to solve it, because there are two parallel lines, right? They have the same gradient. So same gradient, same gradient. So in a situation where we are solving system of linear equation where they have the same gradient, that the equation have the same gradient, meaning that they will never intersect, and for that matter, they will have no solution. Such equation is considered to be inconsistent. Are we clear on that? Yeah. Now, for the consistent one means that there is a solution. There is a solution. Now, here the solution can be of two types. It can be a unique solution, or it can be what? Infinite number of solutions. Now we look at situations where this would occur and this will occur. But in our case of solving system of linear equation, we are going to focus on the consistent ones, where we are going to get either a unique solution or infinite number of solution. Right. Now, uh, now let's see. Let me erase this. I'll write them down again. Finish with this. So we said that we have the inconsistent. So let me draw these two graphs. So I have this line, and this graph. I have this line and this line going this way. So here I have y1 is equal to mx plus c1, x1 is y2 is equal to mx2 plus c2. Here I have y is equal to mx plus c, and we have y is equal to mx plus c, and we call this 2 x2 m2 y2 y1 m1 x1 c1. All right. Now here, these two equations do not have any chance of meeting. And so these two equations, we say that they have no solution. No solution. So because they have no solution, if I'm going to solve them, we consider them to be what? Inconsistent. Now if you look at these two lines, this is the first line and this is the second line. Now they intersect at a point. Now see the point they've intersected. So because they've intersected at a point, they are going to get an x and y coordinate, and that is the solution. You get it? And these solutions are unique, and so they will be under the consistent. So the consistent has a unique solution. Unique means that the solution is one. If x is two, x is two. X cannot be two, three, four, five. You get it? Or x does not depend on another thing. Are you okay? Now let's look at this graph too, where I have a line on top of it. There is another line exactly on it. Another line exactly on it. And so if these lines are lying on each other, means that there is going to be many solutions that can be gotten out of this. And so this gives us the word infinite, infinite many solution, infinite many solution. Have you seen that? All right. So let's focus on the consistent ones and how to find the solution for a system of linear equation. So in this case, so when we are given a system of linear equation, a system of linear equation, or we are given a number of equations, and we are supposed to, for example, we are given five equations, five unknowns, or we are given uh, two equations, three unknowns, or we are given four equations, four unknowns, right? Now, in that case, we there are so many ways of finding the unknowns, and one of the way is using metrics. You can go by the, how do we call it, the normal change of subject and solving it. By there are so many ways, and one of them is the metrics approach, where we use Gauss-Jordan reduced row echelon form to solve it. We uh, can use iterative method to solve it, but at your level, we are not going to look at the iterative method. I think basically we use the Gauss-Jordan elimination, that is reduce row echelon and row echelon. That's what we are going to use. So let's see. Let's take some example and see how best we can solve it. So we are given an equation x plus y plus 2z is equal to 9. Then we are given 2x plus 4y minus 3z is equal to 1. Then we are given 3x plus 6y minus 5z is equal to 0. Now we can write this system of linear equation in the matrix form. The form ax is equal to b, where a is a matrix that consists of the coefficients. So a is a matrix that consists of the coefficient of each of the unknowns. Then x represents the unknowns, right? that is x, y, then z. Then the b refers to the vector here. So b is a vector. So if you want to make the matrix E, we take the coefficient. So coefficient of x here is 1, coefficient of y is 1, coefficient of z is 2. So this column we are using is for x, this column we are using for y, this column. So don't interchange them. So if you are using your first column for x, second column for y, and third column for z, make sure that always the coefficient of z will be in the what, third column. The coefficient of y will be in the second column, coefficient of x will be, and so on. So the next one, coefficient of x is 2, coefficient of y is 4, coefficient of z is what, 3. Here is going to be 3, 6 minus what, 5. So we are done with the matrix. Then the x, oh, this is what, minus 5, this is 3. Now the x, what is first x, what is second y, what is third z? And it's equal to what? The b's. What are the b's? 9, 9, 1, what? 0, right? So there's it. So now we can transform equations into what? The form ax is equal to what? Now with this in place, we can write the augmented form of this, which is, we write the matrix, then we put the vector side here, 9, 1, 0, and this is the augmented form of the matrix. The augmented form of the matrix. So this is the augmented form of the matrix. So let's see. Let's see how to do this. As I said, there are so many ways to do this kind of thing. Let me see. If I can copy this part. Oh, okay, so let's see. Now this is our first rule. This is our first rule, second rule, and our third rule. Now we use the first rule, so we are doing Gauss Jordan elimination. Gauss Jordan elimination. So here we take a pivot. So this is our first rule. We mostly use the first rule as our pivot. So this is our pivot element. We use this pivot element to eliminate the ones here, right? So I want to eliminate the elements under the pivots of my first rule. I want to eliminate it. So rule 2 will be what? Rule 2 minus what? Minus 2 over 1 multiplying what? Rule 1. So here, this is what we do. This is what we do. Let me explain this. Because I'm using this as my rule to do my elimination, to do my elimination, right? To eliminate root 2. So it's simply root 2 minus a 2 1 over a 1 1. That is the element here divided by the element here, multiplied by 1. If I want to eliminate root 3, this one here is simply root 3 minus what? A 3 1 over what? A 1 1 multiply what? Root 1. And that's how I do my elimination. Right? Now I know that if I do the elimination, this will go to 0, so I will not waste time. So I'll start from here straight. And our time is running up, so that's right. I think we have to continue. We'll continue another time, but let's solve this one and see how best we can go about it. So we have, I know that this will be 0, so I don't waste my time solving. So I come here. So I have 4 minus what? What is A2? And that is 2 over what? 1. Multiplying 1, which is this one here. And that will be 1. And this is going to give me what? This is going to give me 4 minus 2. And that will give me 2. Then I'll do same for this. That is minus 3 minus 2 over 1. Multiplying what? 2. And that will give me what? Minus 3 minus 4. And that is minus 7. And I do same for this. That is 1 minus what? 2 over 1 multiplied by what? 9. And that will give me what? 1 minus 18. And that is what? Minus what? 17. Right? Then I come here. This will be eliminated. So I take here. So that is what? That is 6 minus what? 3 over 1 multiplied by what? 1. And that will be what? 3. Then I do for this one minus 5 minus what? 3 over 1 multiplied by what? 2. And that will give me minus 11. And I'll do same for this. That is 0. So 0 minus what? 3 multiplied over 1 multiplied by 9. That will give me minus 27. And so our new entry will be like this: 1 1 2 9 0 2 minus 7 what? Minus 7 minus 17. Then 0 3 minus 11 minus 27. Now I have eliminated this, so I want to eliminate what is here. So this will be my new pivot, and I'll use it to eliminate this, right? So my R3 will be what? R3 minus what? 3 over 2 multiply what? R what? R2, right? So if I do this, this will go to 0. So I'll start from here. So minus 11 minus what? 3 on 2 multiply minus 7. And this is going to give me what? Minus 11 minus, how do you call it? Sorry, plus 21 over 2. Let me erase this side.